Okay, we're working with these three main ideas: domain, range, and end behavior. And any set of points has those characteristics. The domain belongs to the x values. The range are the y values, if there are any. Like this number line, it only has x values, right? But if you have a 2-number line graph, and there's y values. And end behavior is what direction is it headed. So the main thing is, remember, x is king. He has the domain. The other one, y, is range. And then end behavior is what direction is it headed. Sometimes there's 2 directions. And in this case, when we start this game, it'll only be 1 direction. Okay, at the beginning. Okay, so you're just using these words to describe the values that belong in the x story. So the domain is x values. The range are y values. And where is the graph heading? So that's how they do, oh, I gotta zoom out a little. That's how they do your cell phone. You know? Your cell phone is made of those 2 dimensions. And let me see if I can get out of this a little bit. Let's see, there we go. So you can read all my stuff. Okay. So if you put it in that, hopefully that reality, this is abstract, but it's not. Where I am standing has a domain value and a range value. Okay, on the graph of the earth. Okay, so that's what we're working with this year, is where are these points located? And what pattern do these points make? Okay? So keep it simple, keep it light, don't get bogged down in the words. You know this is your game plan all year long. So I always think x is king, and kings have domains, then y is the other number, range. So y's got a job. But like on this number line, these are just x values. The horizontal axis are the x values. And there's 3 different ways we can write in symbols the x values that are marked on this graph. Okay? The inequality x value is x is greater than -3. Do you remember the greater than, less than symbols back in the day? Lazy L is less than, the other one's greater than. As well as, you see how that's pointing to the right? That's the direction the graph is going. So you guys have to make your own story so you can remember these things, okay? You gotta make your own story. You gotta make it yours. I can tell you my story, and if it makes sense to you, you could use it. If it doesn't make sense to you, you gotta make a story so it makes sense. That's success in math. Okay? Now set notation is just an inequality with fancy pants on. You put a curly Q, and you're talking about the letter X, and this little long bar means such that in math. And then we write the inequality notation inside the brackets. Or braces, I guess they're called. Another thing I didn't comment on, you see how that's an open circle? That means it's not a negative 3, but it's everything right up to it. It's negative 2.99999, as many nines as you want to say. Because there's another one closer, but it's not a negative 3. This is pretty simple. This is crazy messy, which everyone you use in different stories. The last one is the simplest of all. It's an interval where you use a parenthesis because you don't include the negative 3. You say after a negative 3, then it goes to positive infinity. Now, on your software, sometimes they put a plus infinity, or sometimes they just put infinity. So I'm going to just keep it simple. And you cannot find the end of infinity. So that's what I love about math. It's unstoppable. So you're going to put a parenthesis because you can never quit. It'll never stop. So whenever you have to type in your notation for infinity, it's always a parenthesis because infinity is not capturable. You tell me a number and I'll tell you the next bigger one. It's just love it, love it, love it, love it. Not only does it go long, it goes deep. Right? Beautiful, beautiful, beautiful math. And so pictorially, this is the graph with symbols. These are the notations. Yes?
So for the set notation, we would always put like the x first?
Yes, if that's the value, if you're talking about the domain, and that's all a number line has is a domain, it doesn't have a range, you put the value you're talking about. So if you were going to write the range with set notation, you'd put a y. Good question. Okay, we haven't done that yet, right? We'll do that down here, because this guy's a two-dimensional. Good question. Okay, because of the arrow, it went on forever. Here, this does have a stopping point. So the inequality, when there's a stopping point, you want to say this is all the numbers between 15 and it doesn't include 15, so no bar underneath the inequality sign. We're doing the horizontal axis, so it's x. But the 26 is included. So then I include 26. So anybody off the street should know 15 is not included in the story, but 26 is. Maybe it's the average age of I don't know, college student. Just, you see, all these numbers could have stories. We work out, first you gotta learn how to write them, and then I'll give you the stories that make them. You just gotta know how to write them first. Okay, so set notation is just fancy pants. Because I'm talking about variable x. And I rewrite my inequality sign. So there's a reason you do that. You know, it's necessary in somebody's story that you have to use set notation. It's just not my favorite. You know, it's just too much. But you gotta use it like in proofs and stuff like that. So it's important. Getting you ready for the next level. So you gotta remember that's the purpose. Okay, so because 15 is not included, I put a parenthesis. And I go clear to 26, but how do I write that in interval? I put a boxed out, I don't know what you call it, on the keyboard. You know, it's a box. It looks like a box. Sometimes I use the words hard and soft. Like this is a hard stop and that's a soft. You know, because of the curve versus the corners. Whatever you want to make it your own story, guys. Make it your own story. When you see a shaded in circle, it is a included interval.
Miss,
Yes.
how come 15 is less than the value?
Oh, the value is between 15 and 26. So if you read it just like this, it's the value is greater than 15. Isn't that tricky? You see, if you read it in math, you've got to be able to read left, right, up, down, sideways. You know, it's crazy. Okay?
Hi, Mrs. Fisher. Sorry to interrupt you. Do you know Aaliyah Clausen here? Can I talk to her really quick?
Yes.
Thank you.
We'll get you caught up. Okay? Okay, you see the magic?
Not really.
Not really?
You're
Okay.
being honest.
Okay, that's okay. What number could go in there and be true?
0.
Is 0 greater than 15?
16.
Is 0 on this list? 16 can go in there, right?
Yes.
Because 16 is after 15, but before 26. Okay, so it's like an in-between. It's a sandwich. This one didn't have that because it went on forever. So if it went on forever that way, we'd have made that a less than, which you'll have an opportunity to do, you know, in your practice. But unfortunately, I can't show you everything. All I can show you snippets and use your logic to try a problem you've never seen before. So because it starts and stops, all the value it's talking about is in between. And for these two signs, they always point to the left. If you're into left and right. I'm not much into left and right, I get lost. But they always go less than. If you have a choice, and they have greater than, that's a liar, lie, pants on fire. Because 15 is not greater than or greater than 26. Right? That'd be a lie. We don't lie in math. It's all about the truth. Right? That's what I love about math too. There is no arguing with 2 plus 2 equals 4. Ever. Right? But you'll get, you know, it'll come, just think about the values. When you see something that doesn't make sense, test some values to see if what you think is true really is. Is it, oh, I'm wrong. Or, oh, this is right. Okay. So those are number lines. They are useful. You'll start your homework with number lines. Then we get into the real deal, a 2-dimensional graph where there's x's and y's. And that's where the word function comes in. Okay, I showed you what interval notation is. You've probably never done that before in your born years. But you see how sophisticated it is? Very concise. I like interval notation. Took the least pencil. A function is on a 2-dimensional graph. It has certain criteria. You see that notation right there? You only use that notation if you're talking about a function. It could be f of x, g of x. I mean, f of x is normal. That's used all the time. It's like calling somebody John Smith or whatever, you know. It's just a Jane Doe, whatever. Okay? That's what you call a function. Because it tells me what the input is, and then the output has to be unique. That's the definition of a function. Okay. Actually, let me tell you that again. The input has to be unique. Okay? So a function is just a graph or an equation, and then this is where you're going to play all year long. I'm going to give you a graph, you write the equation. I'm going to give you an equation, you draw the graph. Okay? It passes the vertical line test. Should have a ruler. If you want, you could use your lanyard too. So if I take and draw a vertical line anywhere on this graph, I'm being random, it only hits one place and one place only. Circles don't fit in that category. And there's several other graphs that don't fit in that category. But how do you know if you have the picture, it's a function, you check the vertical line test. Now, mathematicians don't particularly like that story because it's like off the street. Like they don't use it in proofs. But going to be a legit mathematician, they want you to use this definition. Okay? X values are unique. What's that mean? That means if I put in an X, there's only one. If I put in a 1, there's only one answer that comes out. I can't put in any other value to get that same answer out. Everything's all unique. Like, you know, the one of a kind, you guys? You guys are one of a kind? Right? So if I put in a 1, I'm going to get out a unique value. If I put in a 2, I'm going to get out a unique value here. If I put in a 3, I'm going to get a unique value here, etc. It's like everything has its own space. And that would be a pickle if that wasn't true because, yeah, they couldn't find you if there was, if I put in a 5 and there were 2 other spaces you could be in, you could die before I find you, right? So you want to make sure you know that the X values in have a unique story. Okay, here we go. Let me see. Okay, we're going to write on this set of ordered pairs. That's all it is. Just like your phone, you can look up GPS. You got coordinates you're at. Okay, every one of these have coordinates. So I'm going to talk to you about how many X coordinates there are. Remember? X coordinates, X values. If I start here at the beginning, 0, and I go to the right, this curve's going down. Is there ever an X that's not on this curve? You see the arrows? That means it goes on forever. Means as long as kingdom comes, there's going to be an X value on this curve. Positive and negative. You just need to pick a different color, whatever color you got. Okay. Okay. Oh, I bled over my yellow there. Could be at 0. This should be at big fat 0. Okay. So how do I write that in my story? Goes forever both ways. Bless you. Infinity to the left is negative. Remember, negative is never captured. I'm sorry, infinity is never captured. Oh, I'm doing it in the wrong notation. Sorry, I'm doing the easiest one first. Okay, it goes negative, and it goes positive. Okay, does anybody need whiteout? I messed up. Anybody need whiteout? You guys caught it before I goofed here. Okay, then I get back up and do the more difficult ones. Inequality is the negative infinity is less than x, which is less than positive infinity. Why didn't I put equal to? Because it cannot be captured. Set notation, set of all x such that negative infinity, x is within a negative infinity to a positive infinity. So, in your homework, you'll type out the inequality and you just type the same thing in your set notation. Okay, so that's like kind of almost redundant, except for the extra fancy braces there. And the set of all x such that. So that's what this means. The set of all x such that. The set of all x such that. Okay, now we're going to do the y's. The y's you talk about from the bottom up. Okay. So it goes from negative infinity and it stops at 3. So the range of the y values, okay? So it's a vertical axis. And it goes from a negative infinity and stops at 3. There's another way you could write this. You can just say it's, why did I put equal to? Because if there's not a explicit empty hole there, it's included. So y could be just less than or equal to 3. So going down like that. How's your brain on that idea? So which one do I use in my homework? Well, look at examples. Okay, and as in Rome, do as the Romans. All right? So which one they have in the examples is the kind you'd use in your homework. So there is a little fuzzy in math, isn't there? Just a little bit. It's like potato, right? How do you pronounce it? Okay. So set notation, squiggle, set of all y such that. I'm going to go ahead and use a shorter version. Y is less than or equal to 3. But up here will help me do the interval notation. Can't capture negative infinity, but I do include 3. Make sense? Make sense? Okay. Once you get it, you got it. You remember what's not included and what's included. If you see it. Now, here's a new idea. And behavior. Of course they can't write it in English. They have to write it in Mathlish. Okay, depending on the direction you want to go. And every problem will be different. So you got to follow the directions. If they have x approaching positive infinity first. Then you're going to tell me which way the graph is going. What's the name of this graph?
Please excuse the announcement. Students, just a reminder, as we get ready for lunch, we're 6 at the table for the round ones, 4 at the high tops. Also, make sure your lanyards are out and visible. Thank you.
My graph is going down. You see how it's going down? I'm going to go here. We've only got so many colors, right? I'll try that. Yep. It's going down. Okay. So the direction, this is like rubbing your tummy and patting your head. Okay? Anybody can do that? Gotta be very coordinated. I don't know what color I want to make this down here. I'm going to use my colored pencil. Okay? I'm going to make it. You see how that's headed down? That's where I got this.
What's the green next to like the eggs and the parentheses?
Oh boy. Welcome to Fisher's World. That is a cursive F. Yeah. And I tend to do that, I'm afraid. I'm sorry. It's, you know, I don't print. I don't write. I'm just a mess. So I don't know who's going to show up on any given day. Okay, what happens? Let's go pink. What happens at X heads to negative land? What's happening? What direction is the graph going? I'm going to do orange. See, I'm going negative, down, which is negative infinity. So both stories say you guys are going to end up in dark places. Not really. It's okay to be a negative number. So that's the code, guys. That's the code. So watch out on your homework. Man, you can't read that pink over the pink, can you? Sorry. I was not thinking, and you can't see it now because the pencil's shiny. It should be negative infinity. Okay, in the homework, they might switch these two around, so watch out. Watch out. Okay? Now you're not responsible for working on the homework yet because we're not done yet. Go ahead and put this in your folder. You know, just pop it in your journal. You can hold it for now, whatever. Just have it ready to take out, and we'll finish the work tomorrow and start on the homework. Thank you for putting up with my less than perfect voice.